Using electric vehicle powertrains, the role of wide-bandgap semiconductors in overcoming challenges and shaping the future trends. Now it's time to welcome our chief guest, Dr. B. Venkatesa Perumal, Professor, Department of Electrical and Electronics Engineering from NIT Surathkal. Dr. Venkatesa Perumal did his bachelor's in Electrical and Electronics Engineering from Madras University in the year of 1999 and did his master's in Power Electronics and Drives from Bharidasan University in the year 2001. He did his PhD in Electrical Engineering from IIT Delhi in the year 2007. He has industry experience for 10 years, where he served as the manager R&D at BPL Healthcare Limited, senior design engineer in General Electricals Healthcare, senior design engineer at Shinter Electricals India, and he also served as technical lead Power Electronics in Sun Edison Energy India Private Limited, Bangalore. Over to his academic experience, he has served as faculty at the Vellore Institute of Technology, and he stepped into NIT Surathkal in the year 2015. Right now, Sir is a professor at the Department of EEE. Over to his academic infrastructure, he had made a deliverant and vibrant publications in IEEE about 14 transactions, in IEEE Condex Conference about 19, and he has completed about 12 sponsored R&D projects, and the total amount of R&D he has succeeded for about 1.8 crores. He was also gifted with grants of patents of 5. Over 4 PhD scholars have been completed their PhD, their research under his guidance, and 2 of them are ongoing. And he has also guided for about 10 PE scholars and 25 UG scholars. Over to his achievements and award. He is an IET Fellow, IE Fellow, Best Research Paper Award in the 2022 WBG-Based Karnataka, IEEE Senior Member, IET Student Projects, where his guidance has been recognized for the Smart Charger, and he stood first in the Masters at Bharidasan University. It's all about his greatness. Now, I request Dr. B. Venkatesa Perumal, sir, to deliver his session. Sir, please.
Yeah, thank you. So I hope my voice is audible, right?
Yes, sir. Voice is audible, sir.
Okay, I'll share my screen. So I have shared my screen. My screen is visible, right?
Yes, sir. Screen is visible, sir.
Yeah. Good afternoon or good evening, whatever it is, you take it. So this is the topic which has been given for me to deliver a lecture. So basically, EMI and noise mitigation in wide bandgap based devices, basically that devices and based on that EV system. So before I start this, I thought this is the forum where I can talk about what is EMI and EMC, because most of the time people talk about EMI and EMC. We don't have a clarity on what exactly we are looking at. So why it is going to come in my circuit. First foremost thing is I should understand what it is, and then I should move on to that addressing the problem, how we can address it. Okay. So most of the time we stuck with that what is EMI. So this is the one which I wanted to show this picture. Why EMI and EMC is the problem. If you look at it, this picture I have taken it from the internet, because most of the time when we discuss about any of the fundamental thing, so the India first rocket launch in 1961 around that time, if you see that whatever they have taken either in cycle or bullock cart. If I look at the reason behind, when we ask for the reason why they have done it through this mode, if you look at it, it is basically the electromagnetic interferences, how it will impact the electronic systems which are there in the rocket. That is the thing. So if they transport the uh, satellite and then the rocket launching thing through the normal vehicle, they thought that it is going to give some effect of EMI, EMCs. So this is also one of the reasons they did this. Okay. So EMI and EMC is very, very important. So blind way of understanding the EMI, right? So electromagnetic interferences. What we say is electromagnetic interferences. I'll come back to that EMC. EMC is if you are addressing the EMI, automatically the EMC will come into the picture and it will be taken care on that. So EMI, what it is basically. So electromagnetic interferences. So when the electromagnet happens, interferences are coming into the picture. Then basically, if I take it my induction motor, the magnetic interaction happens with the nearby material. That's why the force is created. It is working, right? The same way, if I look at it, certain frequency level, if it goes, so because our surrounding is having all kind of a signals. So when we transmit some signal from the power supply, because initially start with, we have a power supply of linear one. Linear one is basically, it started with the loss and other aspects. So basically, to minimize the loss, we moved into the power converters, wherein the power converters are started switching at the frequency of 100 kilohertz, 200 kilohertz. They started switching at very high frequency to get the power density. Here, what I mean is power density. Basically, I am talking about the weight and size of the converter, which is going to be very small. When we need to make it that the converter is very small, under that condition, we increase the frequency. That too, if I look at it, silicon carbide device or gallium nitride device, if you are using it in your system, then your switching frequency is going to increase. So normally, how we can identify whether it is emitting the EMI and what way it is impacted. One is conducted EMI, another one is radiated EMI. So in the EMI itself, we have a conducted EMI and radiated EMI. So just because I thought in an overview, just you people should realize what exactly it is. In olden days, basically in 90s or in 1990s, if you see that the radio receiver, when the mixie used to run, it used to pick the noise and it used to give the uh, noise added into that amplifier, and it will give the sound along with that. Basically, the radio frequency signal is received by the receiver, and the radio is processing that signal. At the same time, when the mixie is running, it is also emitting that. It is happening in a two-way. One is the mixie is connected in the same, basically in the same power supply way it is connected. So it is a noise is transmitted through the conduction. Also, sometimes if you see that, if you would have come across some bullet is running around there, so it hits that and it comes back. The noise will interfere in the tube TVs. You could have observed that the pixels getting distorted. Recently, we have a LED TV, so we will not be talking about this. But in LED TV also, it has the power supply that has to comply with EMI. So EMI basically, for in general, electrical product must meet some type of electromagnetic interferences, preference matrix. What I mean is how much I can radiate, how much I can pass it through the conductors. So basically the conducted emission and radiated emission. These things need to be addressed. So that is where the people talk about the standards for EMI. That's people talk about the standards. So when you design specification for your product, that time itself, the regulatory comes into the picture. Why Indian products are not coming into the product shape is because most of the time meeting my compliance requirement. What is that compliance requirement? How much I should radiate? How much I should radiate? I should know how much I am radiating the signal from nearby component where I'm connected. So see, if I downsize the same EMI to make it more understanding, you can think of the harmonic content present in the voltage. So if the harmonic is comes because of your converter is switching happens, so it makes that the supply voltage polluted, right? So basically, because of my converter circuit, supply is getting polluted. This I need to make it come out of it, because when we look at it, the three-phase rectifier, normally we put the three-phase rectifier, but in practical, when the changeover happens from one switch to another switch, where the other one is would have the top diode and bottom diode from the one phase to another phase, or in the same top diodes are getting into the conduction. That time there will be a short circuit time wherein the source inductor comes across the system supply voltage. These are all the possibility of making that the conducted EMI I'm talking about. It is important to take into the account of any functional specification, that is split limit for EMI during the design phase of the project itself, particularly with respect to PCB design, layout, and noise filtering. Why did we talk about that? The PCB design itself, it should be taken care, because if you see that, we know that the magnetic couple happens in the telephone cable, the landline telephone. Nowadays, we don't use that telephone, but if at all, if the telephone is there, the receiver wire which is connected, it is basically the spiral kind of a thing which will be there. It's basically, it gives that the electromagnetic cancellation, the noise cancellation happens in the wire itself. And sometimes we use the twisted pair cable. Basically, it gets that the noise is getting cancelled. So that is the main thing which we are talking about here. The PCB is also, when we design the PCB, we have to clearly think about my routing, how it is going to make my EMI to be very less. standard for conducting EMI, uh, conducted EMI in automation, automotive, communication, and industrial application. So actually, the conducted EMI has been applied for three different categories. In this particular FDP, which is going into the automotive thing, it is also applied in communication area and industrial application. So when if you see for that standards, sorry, before going into that automotive or industry or consumer electronics, communication or industrial application. Again, consumer electronics is also having a different standards. So first we should know what exactly it is. So commonly specified terms, IEC. IEC is nothing but International Electrotechnical Commission, where they were dictating the terms. Because I'm emphasizing this particular term again to the all faculty members who is attending when they wanted to buy particular equipment, either digital signal process, signal oscilloscope, DSO, or any devices, measuring devices. When you are buying equivalent source, AC programmable source, DC source, when you buy, don't put the specification which says that my voltage need to go from this voltage to this voltage. Current goes from this voltage to this current is support, and the power level. That is not enough. You should specify that IEC standard. So it makes sure that you are getting a quality equipment for your laboratory purpose. So the different kind of compliances which are for the EMI and EMC. In this particular slide, I have put particularly for that purpose. So first one is IEC, the International Electrotechnical Commission, and CISPR 25. This is basically the Committee International Special. D is basically it's a German, the engineering participation of radio techniques, basically radio electro technique. Basically, it is comes into the picture. IEC technical committee, basically that again the technical committee is comes. EN 55032, a modified derivative from that 32 CISPR prepared by this particular agency, CENELC, and ratified by that thing, because previously they were having a different standard. It has to be ratified and it has been used in a different way. Subsequent slides I have put what exactly it is meaning. FCC is a part of 15 Federal Communication Commission, and Part 15 Subpart B applied for unintentional radiators. So basically, whatever the signals which is goes. UNECE, United Nations Economic Commission for Europe, CE marking for comfortment European symbol. Basically, it's a Euro. CENELLEC. So Committee European Engineering, basically D is nothing but engineering. Normalization of electrotechnique. EN is European norms. So if you look at it, everything is dictated by the Westerners, what standard is required, right? So the product, when it comes to India, what kind of things which we need to look at it, we are not into that level where we are dictating the terms for the standards. So most of European standards are suits for Indian application. So that is why people most of the time goes with the European marking. So basically IEC and the EN marking, it will be there. Particularly if you can see that any of the product like a solar panel backside, you go and see the data sheet, they would have mentioned that this is the IEC 64000-2 or some that kind of a number. So each one is indicating that what kind of a test and what way, how much it is radiation is going to come. That is what it is specified over there in that system. Now, it is for automotive. When it comes for automotive, from the regulatory standpoint of view, the UNECE regulatory body, basically the 10 title uniform provision concerning the approval for vehicle with regards to electromagnetic compatibility. This is the main thing for electric vehicle application. The standard which is talks for specific to the automotive thing replaces replaces basically European standard. Previously, I was talking about that the Directive 2004 this /104/EC, which was done in that for European vehicle market, what exactly it has to be done. So UNECE regulation 10 requires the manufacturer gain type approval for all vehicle. It is talking about if it is an electric vehicle, complete electric vehicle need to comply with this. Apart from that, so because when we talk about vehicle, one of the component is electrical. All other mechanical aspect is also comes into the picture because the complete chassis, everything is included, right? So braking mechanism, even if the electric braking is it goes off manually, it has to validate. Like mechanically also, it has to support when we do the braking. So here, the complete vehicle need to support this regulation 10. Also, the each and every sub module, electronics, sub assemblies, components, and separate technical units. Whatever it is linked with that, it has to comply with this. So what complies it is basically, of course, the automotive manufacturer has evolved that global business and requirement standards are specified as border reveal then. So because it is goes keep on, it is increasing because it's not going to be bound with one country. For automotive electronic product designer perspective, CISPR 25 product standard specific is critical. Conducted emission test that applies both overall vehicle level as well as the automotive component and modules level. Again, this is the standard number which need to be complied with. Even when we go for buying an electric vehicle, we look at it how much mileage it is giving and what kind of things are how much charge it is going to withstand. We never look at it these kind of compliances whether the vehicle is pass or fail. The meaning why we have to be very cautious to that automotive thing is if the product is kept at one place static and if you do all kind of a test because it is going to radiate in within the certain distance and also the conduction will happen. We can through that keep connecting points where it is going is here in the case of vehicle when it is moves in a road, the temperature ambient condition is completely changed. Also, the speed at which it is going, it makes that difference. And if the two cars are near, if the one car is emitting the noise which is interacted by the other car, what it will happen? So you can think of how much it is important for the automotive when we look at it, that EMI, EMC, wherein we have to see that more stringent conditions are there in this. Measurements are performed. Actually, here when you wanted to test the unit, whichever the unit you wanted to test in automobile part, one or two 5 microhenry 50 ohm network will be created, depends upon the ground configuration, whether common ground or a floating point, whether chassis is connected, it will be checked. The conducted noise is measured over a frequency range. This is the frequency range is given. So you can see very clearly it starts with 150 kilohertz to 108 megahertz. I'll come back this in the next slide, how it is going to impact on my own design, right? Because of this CISPR 25 refers that the protection of onboard receivers, the relevant frequency bands are dispersed across this amplitude modulation broadcasting, frequency modulation broadcasting, mobile service network. See, I have put the thing in the next slide. The limit is in the red color and pink color. Average and peak values are given over there. You can see this is the picture. So the peak value, when we are talked about that 150 kilohertz, this is my 150 kilohertz at this point, right? It starts for the lower waves and medium waves, and then the higher band and very high frequency band FM where it goes. So the frequency starts with 108 megahertz they were talking about. Here up to this point it is given. When the frequency is increasing, your band noise, whatever the conducted one which is comes for this emission, this is the standard which is for conducted radiation, which is conducted emission, which happens in the system. The blue one is talks about average, red one is talks about the peak value. So you can see that the low frequency can emit more values. Okay. At the same time, very high frequency, low values. So the other side, what we always say as a power electronics engineer or a designer for the converter, we normally do what we do is increasing the frequency. When I'm increasing the frequency, it starts at 150 kilohertz, right? 150 kilohertz. If your switching frequency is lower, if the switching frequency of the converter is lower part, you will not face the issues much. But if I look at it, the wide bandgap device, if I look at that wide bandgap device, wherein which I wanted to switch it up very fast. Right? So basically here the energy transfer is very fast. It happens because of the wide bandgap. So we wanted to operate this particular devices in a very high speed. When I operate 1 megahertz, this profile which I given is, this is only CISPR 25 class 5 conduction emission limit. This is the standard wherein the limits are given. this, if I operate my converter at 1 megahertz, definitely there is going to be a conducted emissions will happen. So we have to address that one. Average value is around 35 or 34 dB, and the peak value is about 54. Okay, so if the frequency is increasing, your design consideration is also going to be a complicated to address the EMI aspects on the system. So basic idea, you can see that the long wave, medium wave, and short wave, where that the waves are the frequency modulation band. You can see here to here how it is going and what is the dB level which was marked over there in the previous slide. If you look at it, this marked values responds to the band of wave where it is okay, long wave, medium wave, and so short wave. Basically, the waves, short wave means the frequency is higher, medium wave, and then long wave means time taken for the cycle is more. So this is basic thing which has come from the standard, which is talking about how much quality I should have. You think of now I have put this is for conducted emission. It is for the conducted emission which we are talking about. Again, I'm re-emphasizing that this is for the automotive application. What kind of a standard need to be followed? Okay, so if this the conducted one, it goes via wire which is connected over there in the system, and it is emits that the energy level of that particular one which we are talking about. Same thing is applicable for your cell phone. That's where people used to talk about that. When you keep the phone, what kind of this is the amount of energy keep on we are going to the amount little bit of amount of energy which is comes out and it hits your. So medically, some of the therapies uses certain frequency wherein it gives that the treatment for some of the tissues where you wanted to activate or deactivate, you can use it. Exactly. Mosquito repellent, people will talk about that electronic mosquito repellent. Basically, it transmits the noise which can be heard by the mosquito, but will not be able to hear it. The frequency will irritate the mosquito. It is dynamic. The same thing here. Whatever we are talking about, this much of energy is dissipated, how it will be. And in a flow, I'm asking that the people before taking an electric car or electric vehicle, you have to do all kind of a calculation. It's not going to transfer in a day complete electric vehicle, right? So people have to think on whether if all the vehicle are on road is only electrical, what it will happen for the conducted emission and radiated emission. Even though if it is within that limit also, the energy pollution which is going to give that kind of a pollution, people have to look into this aspects too. It's a kind of a research area which I'm telling that where people can talk about this model can be developed. The model can be developed. So how much this conducted emission and radiated emission on EV when it goes into the on road, every cars are going to be in a way of it is completely electric vehicle. So the from this figure, basically I was talking about this, the range at which how it is extremely challenges because our the values wherein getting this much value is very difficult for the designers. So this is basically leads you um, this number basically leads you a PCB designer. People are thinking that the PCB designer job is not the very high profile, but if you look at it, these kind of aspects, if that expertise area that has been developed, it will be very, very helpful. Also, this is indicates that if you use that Intel motherboard, it's a 17 layer or 18 layer board, where the signal integrity is also very, very important when we are operating with the clock frequency. Here it is this particular one is for the automotive application, but if you go for the consumer electronics or electronics component, there it is going to be again very, very challenging one on this aspects. So European Union regulation limits this basically with that. This is what I said. What was the thing is that directive which we were talking about in 2004 or 14, they have changed it, this particular one. The Europe and equipment does not cause intolerable electromagnetic disturbances. So what exactly this directive, they made it on that particular one, when it is comes to that, we should not cause any disturbances. Equipment can perform intended without degrading the presence of electromagnetic disturbances. Basically, it is also what it says that, yeah, interferences and compatibility. It is for the compatibility. Even if you put your equipment very near to the magnetic emitting circuit, it should not get disturbed. Guarantee for free movement of equipment within that internal market. So basically, that is for market application where they move, nothing is required. So how does that directive applies is the equipment must comply with the EMC directive for placed in market, takes place for the servicing and other things. Manufacturer must make the product CE marking conformity, basically declare the conformity where it will work for every conditions. So this basically this is for immunity against the radiation, also conduction, it has to work very well. The other standard which is for the EMI, which I wanted to specify for this case is why I'm talking is here the topic where wide band gap. It is also relevant to the electric vehicle application. Also, it is for any application. Most of your attendees are going to be electrical engineers. If I look at it, even the satellite won't work without power supply, right? The power supply is going to be the heart of the system where the heart is stopped, completely everything is going to stop, right? So without power supply, none of the equipment is going to work. So making the product with the good compatibility, basically all the standard meeting requirement, which makes that the radiated emission or conducted emission to be within that limit, and you can get it. The power supply product marked in the communication. So marketed for the communication product information technology, basically ITE within Europe. So this is again the classification number. These numbers, why I am telling again and again is these numbers are more or less common. EN 55023 2223 and 33. These numbers will come so that you can also easy to remember that why it is coming, uh, in what frequency range it is coming. Okay, that is the main thing. You can see that European nation 5002 and class A and class B, both it has to work. Class A and class B conducted emission with the quasi peak, where it is the average values in this range. It is only taken. You can see that the range in which it is operates. If I talk about this is for the communication equipment, how this band has to be there in the system. So I don't know if you come across with the measuring device when the product is ready. If you are wanted to check your compliances, if you put it that your compliances, basically the test equipment on table, and if you perform that test work, no load test, full load test, half load test, variation in input, variation in the load, any kind of a perturbation when you do for the different thermal conditions, when you do that, whatever it is emitting, okay, EMI or electromagnetic interferences through the conducted or radiated, what it happens. That values, whatever we are seeing here, the average component should be lesser than this value. And the peak component, it has to be, you can see that the peak value on the red, and this, this is only the standard which talks about, because here you can see that it is from starts from the 30 kilohertz and it goes to 150 kilo. So, sorry, 130 kilohertz. So 30 megahertz, 150 kilohertz to 30 megahertz, correct. It's a 10, 20, 30 megahertz. This is the range which is for any product which is a communication related or in the consumer electronics, also tested only in this particular range. 30 kilohertz to 130 30 megahertz. Okay, so that is the range. They are 150, sorry, 150 kilohertz to 30 megahertz. This is the value. And you can see here after that 5 megahertz, after the 5 megahertz, again the value is going. This is for the class B and this is for class A. So if it is a class, if the class B, the conditions were changed, you can see that operate the emission frequency itself, it is determining how much variation it has to have. Here you can see the class A, it is a constant, and class B, it is variable. Up to this point, after that, you have a cushion of here to this value is 13. Again, it's a 10 differences are there. That means this condition, meeting this condition, is going to be a crucial part for the system. So similarly for that, so North American market, the design is basically FCC, which is a part 15. This has to be met. So CISPR 22, which will give that the standard which is similar to this. It's border, basically this countries, different things is going to be. Again, EMI standard for industry equipments. If you see that CISPR 11, which is the international product standard for EMI disturbances from the industry, scientific and medical equipments. So the when we look at it, this equipment, we need to meet this particular one. Here again, it is classified into group 1 and group 2 for the general purpose and radio frequency application respectively. So each group, if you see the group A, class A uses the establishment of other than the domestic and many other measuring test site and suit for this particular one. covers that domestic establishment in measuring only in the test site. So if you see that that I was talking about IEC standards. So when you look at it, that IEC standard, this is the particular one which we wanted to make it. So these are all the numbers as to be generic one applies for the product targeted to the residential, commercial, light industry and industrial environment. The particular product for the standard which is unavailable, where that this is the number which we need to maintain. You can see again, this is the one which is to be, right? So most of the time we say that the local market product is very, very good, but not that the radiation aspects, we will not be able to check it on this particular one. You can see that in the two things are given: class A peak power and class A average power. Here, when you look at it, this is a 79 dB microvolt, and then here 66 dB microvolt for this particular case. And again, you can see that the 10 difference which is coming over here, and then the variations are there. This is for basically the average and the group 1 and group 2, which we were talking about different classifications where it wherein group 1 and group 2 it is going. So here you see up to this point, which we can talk about the EMI, what exactly it is. So just I wanted to show, this is my experiment test setup, wherein I put my test unit. Okay, so basically the unit under going to be test. What kind of the specification is given? You can see that here, this is the unit and this is the equipment. Now, we are talking about one is industry, one is communication purpose, another one is for the vehicle application. If I need to test this particular equipment, those equipments need to be having a higher test range than this. That's what I wanted to say here. The equipment which is used for make that test on this particular one, it should have a higher capability than the normal one. You can see that the previously it was a 35 kilohertz to 130 megahertz it went. But in this case, you have to see here, it goes up to the 108 megahertz. The higher side band on the measuring equipment which is going to be used for the EMI, which is going to be 108 megahertz. The other standard, three most commonly referred standard for this EMI thing is 55011, 50014-1, and then 55032 based on this particular ones as there. And also the lower ones, when we look at it, the lower frequency, previously it was a 30 kilohertz, and here now it is 9 kilohertz. So the band of the equipment which is going to be used for the measuring that EMI, it is altogether again a wider band of the equipment is used. Looking at that, the summary on this particular standards for automotive, whatever the thing is we wanted to use is, this is the base standard, this is European nation standard, and FCC standard is for multimedia. Basically, multimedia is nothing but a communication one. So this is 32 and 55032. You can see that the number, last number, it kept it as the same to more or less these variance between this Europe and the countries where that it is not going to change. Okay, household application and light equipments. This is what the part 15 and 18 is combined one, and 15 it is going to be there. So this is for the base which I said, wherein my EMI, the most cases what we think is, what is that EMI, what is that EMI? Looking at simple way, the thing is the test setup is needed. The test room should be a clean room, and also it should have a very clear observation. Basically, the measuring equipments in that room should be a high-end equipments wherein we can get all the things. The thing is, which I wanted to say, how I'm going to apply this particular one in a um, in my circuit. So just which I thought I'll give an real design itself, wherein you can get into the system understanding, because most of the time when we talk about EMI, which I spoke up to this point, is more or less it is talks about the standards which is telling what. But when real time, if it comes, what I need to do is in TI website. This is the website I have. I'm in right now. Directly, if you go here, there is a design now. So basically, if you wanted to design now, if I click on this particular one, I'm getting that which power supply need to be start with. So basically, here most of the cases AC to DC it is taken care, because the input side is basically a 50 hertz component. So I'll start with the particular circuits or in the DC to DC converter. If I look at it here, I can put it 7 volt to 30 volt input, and output I'm expecting 3.3 volt and 6 ampere. If I type that input requirement for this, if I do this viewing that design, this particular TI website, we can get that design of a complete DC to DC converter, wherein we can look at it how the EMI is going to be operated. Okay, so just it is taking time, but if you see that, it will give you a good idea of what it is, what is the EMI. Just so previously I have done that. So anyway, if it comes, it is okay. So this is for the different purpose. I have done it. You can see here what is the efficiency. I'm looking at it. Phase margin, gain margin. You can give here what is the switching crossover frequency, inductor ripple current, how much it is to be given. So if I see that the custom design wherein I have put that already, it has come. Just wait, I'll see that. Okay. So if I do that, this particular thing will come wherein they are talking about what kind of a system I have to use it. So if you see that here, the module level, basically the modules are used, converters and controllers. Controllers is basically a IC which will be coming for the controlling purpose. I am just clicking that wherein the controller directly it has come. So these are all the options again it is giving. The site is very slow. So if I look at it, these are all the options were given. So I'm just clicking one of the package wherein this is my design. Again, if I take it this custom design on this particular case, okay. So you can go and see this add input filter. So here you can do the simulation and you can do that the performance variation, everything is possible in this particular case. So still it is working. So anyway, this particular exercise I can show it to you. So because I just put that, if you see that the bill of material, what all the material is required for this, it has come. We have given the maximum input voltage is 30. Maximum output current is a 6 ampere. So with that, it has been calculated everything, right? So this is my schematic wherein the EMI filter is not incorporated. So if I do this, add a filter, you can see that this particular one, which is talks about that input noise magnitude, how much it is coming, and the color line, that the gray color line is already a one which is there in system. We were talking about CISP R25 and class 5. You can see here it is given. You can select any of these things. If I selected this particular one, CISP R22, it is showing that it's a constant one, that the peak value, wherever it is going to be. You can see that noise before filter, it is there. If I give next, the filter is not applied in this particular case. Here also you can see that this is the noise level at this point. Okay, we can even do that. The class 1 means you have a more margin. You can see that the class 1, when I put, the margin is very high. You see that the line is changing. So if the class number is going higher and higher, it makes that the stringent condition which is comes out over here. Now I have put 25, and also if I say 22, it is already going up. So the 25, the higher number, and here also I have given higher number. But the total noise now without filter which we have right now is, this is the particular one. If I give this, you see it is talks about the input side, how much inductance and capacitance I have to add. It is calculated this much milliohm and 1 microhenry. If I add it with this supply, you can see that this is the one in my design where it is going to give me my value on. You can see the profiles, whatever. This is a ripple spectrum where the magnitude it is going on, and sorry, this is a duty cycle, the input current, input current, how much it is, how it is varying. You can see here, this is after the filter. This is, if I am not putting that particular filter, your EMI is not going to, that the peak is changing. When I added my circuit, the EMI filter, it is not crossed this particular case. So here, sorry, you can see this, the level of the specification says that it should be, noise specification says that 53.99 dB microvolt volt it should be there, but after the filter we are getting 47. Here the condition, whatever we have put, that the condition what I have is the class 25, and then the other one is also 5, right? So if you look at it, we put it that 25 and 5. Now what we reduced the value is also come in a different way. If you note down the value, line impedance, that is, sorry, here if you see that, yeah, so it is basically the line impedance before. Now you can see that the filter, which is, this is basically line impedance, sorry, this is the one which is component, the filter component which is added over here. You can see that this is the value. It is basically a 230 nano henry, and 230 nano henry plus whatever the values are there, just I'm taking it into that value, and just I'm making it back. Here I'm changing this one to 1, right? And if I make it, already it is there more or less. So we need very less component over here. If you look at it, this is the line impedance which is there. Next, if I do that, the value which has come from previous case to this case, if you see that the previously it was a LF is a 330 nano henry, 3.9 microfarad, 10 microfarad, and 10 milliohm. So here these two components, if I see that LF and CF, it is changed drastically. Here also you can see the number which is comes out over here, it is getting changed. So this is for the class 5 and then sorry class 22 and then 5 which we have put. So if I remove that filter, it is going to be again we have to check that what count. So both are 5 5 I'm keeping, and then you, you can also see for this, right? In 22 class A, B only will be there. So it is so B is a stringent one. You can get it. Again, the values are different. So this is for the class B. Okay. 25. Yes. 5. Next, if I do this, I'm getting the complete add to my design. If I do that, so my complete circuit, you can see this particular component here, whatever the component which we are there, this CF, LF, and then RD, and then CB, basically these 4 components is acting as a EMI component for this particular network. So basically, you are putting a kind of a filter. You are putting kind of a filter wherein it is not allows the outside noise to transmit to inside. At the same time, whatever you are creating, that noise also not going out. So here in this case, you can see that 6 volt to 30 volt and 3.3 volt is my specification and 6 ampere is my condition. With that, I have designed over here. If I look at it, I think for this particular case, the simulation is not available. You can do this simulation also some of the cases wherein you can get that the step response just once again. So you can see this particular one, sorry. So I have done the same setup. Here you can see this particular one is a LNC in this. And if I look at it, this simulated one, I have done it already, the simulation. You can see that load transients, what I have done it. You can see that the load is a current variation. Full load current is a 6 ampere, 6 ampere to 0.5 ampere, and then so when the load is rejected, output voltage goes up and it comes back. The ripple here is 0.1 volt, 0.1 volt. You can see that the point 3.332, 3.32 to 3.4442 it goes. So basically 0.1 volt is the difference it is coming over there in this particular case when the load is changed from a higher full load to no load, again no load to full load. The input transients, basically the input voltage also I changed from the value which is given here 6 volt to 32 volt. So when the 6 volt is there, it is goes here. When the input is becoming a 32 volt, it goes like this. You can see that there is a stability issue in the output voltage. Still, it is not settled, but it is up to that 800 microseconds. It is going on this. Actually, this particular device inside there is a MOSFET. which gives that leakage path. Because of that, the emissions are happening. I think you can add the waveform also here in the um, um, voltage or current, whatever the waveform which you wanted to add. You can add that waveform. This is under the steady state condition. What is that exact output voltage for the converter, where we can get the output voltage ripple calculation if you want that you can get it. So you can make it zoom also, how much ever. So you can make it that particular one, and you can see that whenever it is changes. The Bode plot for the system is drawn over here. One is a phase and another one is a gain margin. So the system is stable. How much frequency it is operating, you can see here. So the complete thing which we can do here in this particular case. So this is for one of the tool which is for the DC to DC converter. Why did I pick that DC to DC converter and this specification? The reason behind our processor, if you look at it, any of the embedded system processors or works with the 33.3 volt. Okay. So as we know that the MOS technology, CMOS technology, basically where we wanted to work, voltage is less so that the power loss in the system is going to come down. So we need a processor everywhere, wherever you are using that, the supply has to go from the 3.3 volt supply. But your battery voltage will vary from that, the fully charged condition to the no load condition. So that variation I'm accounting over here in this particular case. And the output voltage I want to maintain constant. At the same time, I want to check my performance on the system, that I have done it over here. So in this particular tool, it is apart from that. The other one which I wanted to say, still that design is not completed. You can sorry, you can do that. Need is new design. Sorry. If you put that AC, which will ask that, this is one of the things wherein your charger part comes into the picture. So you can give that the output voltage is 12, whatever it is, 48 volt and 4 ampere current. So if you do this, the tool is taking care of my complete design, and I'm doing it with that. So most of the time, EMI and EMC is a kind of a filter component. Either that inductor or capacitor, we will be adding it. You can check that the EPCOS, EPCOS website. There also they would have given kind of a system wherein you can work with. So you can see this is it is a two design it has given. Here it is not specifying anything about that. If you look at it just once again, if I make it that particular one here, it is not going to show me any filter design over here, because already this particular part, you can see this in this particular case, you can see this is the part which will act as a EMI filter for my input side to that AC to DC converter. So basically this is a Y capacitor, this is the X capacitor. The CY it is mentioned, Y meaning is it is going to be connected with the ground. The capacitor, the manufacturer itself, he will specify that the Y capacitor and X capacitor. Normally the X capacitor between line to line, it will be connected. Line to neutral also, it will be connected. The ground connection, when it comes, that the capacitor is going to be a Y capacitor. You can see that. See here, it is a X capacitor. This is capacitors are called X capacitors and Y capacitor, and the magnetic. This is taking care of my EMI at this particular case. In this case, the main thing is what the thing is in this particular case, The transformer is the one which is going to be, because both the sides you need a isolated supply for operating my converter also. Okay, so you can do the simulation in this case also, no simulation. So if you want that transformer, this is the choosing the alternate. This is also gives that what kind of a custom parts where you have to apply with. Okay, so because basically the transformer is not given, you can see this the primary inductance. What is that the value of the inductance leakage component, and then the magnetizing component parallelly, whatever it is coming current, you can edit it and you can get it. The transformer specification also will be given by this particular design itself. It will come. Okay, if you download the bill of material, you will come to know what kind of a component is needed for your circuit. So complete design is also given over here. The apart from that, if you are looking at this particular case, you can see that this is the transistor. This is basically the beta value will be very, very high on this particular component. You can see that this is not an optocoupler. It is transmitting the data 0 or 1. It will work in a linear region. So to control that, normally this particular component works in a linear mode. So what it happens is this beta value will be around in the range of 200, 150 to 200 value it will be there. Okay, so I hope I have done it my presentation. If you have any question, you can ask me now. I think I'm done with my presentation.
Participants, if you have any queries, kindly post it in the chat box. The session is open for conversation. Sir, I hope there is no questions. Thank you very much, sir, for accepting our invitation and providing a nice presentation uh, with regards to
Okay, yeah, this
EMI.
is a, I understand that this is a dry area. People are not concentrate on this
Yes, sir.
particular area where
Yes,
it
sir.
will
Yes, sir.
be going.
Yeah,
Actually, this gives that lot of research insight on people. Whoever wants to work on this particular area, please drop a mail. So, or if you are clearly working with the planar transformers or any other inductors and transformers wherein you can use it. Design with the input side filter, you can contact me. No issues. Okay.
thank you, sir.
Thank you.
Thank you for your time, sir.
Thank you. Bye.
Thank you, sir. Thank you.
Participants, the feedback link is posted in the chat box. Kindly fill the feedback link. The next session will be by 5 p.m.